Okay. Good afternoon. So from the previous presentations, I think there's no doubt that we agree that the air pollution, indoor air pollution, is a problem, and it's a serious problem in China. And so I think what I'm going to talk about is really to look at the possible solutions, how to solve that problem. Well, obviously, these are not the unique solutions. So what I like to say is we want to divide roughly divide the Chinese population by half and half. On the left are those people who are living in the rural areas, and they are mostly exposed to the particles due to the combustion of coal or biomass. And on the right are another half of the population who are living in the urban areas, and they are exposed to many, many pollutants. However, I want to overly simplify this as the chemical emissions or improper ventilation. So the exposures are different, and now recently, we also have this new evil like the haze or outdoor air pollution. So this adds the complexity of the indoor air pollution. So of course, we want to see the risks, and so based on and the highest risks are really the mortality. So based on this ranking, we find that certainly on the very top, we have the, we have the ambient pollutant, particularly particle pollution that cause a lot of problems, the cardiovascular, circulatory diseases, and also the chronic respiratory diseases. And the household air pollution from solid fuel also rank very high. So, we first of all, let's see if we want to prevent the ambient pollutant from entering the building, then there are some solutions. For example, if it's very polluted outside, then you close the windows. That can help a little bit, but may not. It really depends on how much air is getting in and how sealed well the buildings are sealed. So that's and also people have talked about use the air cleaners, whether it's centralized air filtration or the portable air cleaners, and there are also a lot of discussions, and people have a lot of concerns. So these are obviously the possible solutions. So, but I want to focus on the indoor generated pollution control. And let's first of all look at the pollution in the rural areas. And so based on our measurements, and actually a lot of evidence have shown that when people use biomass or use coal to heat or cool, or to cook or heat, then the particle concentration get to very high level. And not only that, but really the indoor particle can get outside and also make the outdoor air quality very bad. So sorry about that. Should I use this one? This is forward. Okay. So
this forward, this back.
This is forward, right? Yes. This back. Okay. So we are working on a retrofit or intervention idea and trying to solve the problem and to propose the so-called zero coal, low energy village concept. So basically, to do this is really you need to consider from different aspects. First of all, we need to make sure that the buildings are energy efficient, or they should have more or less requirement in terms of heating energy. So we need to improve the thermal envelopes, insulation, and also try to use the passive energy. So by doing this, we could probably save 60% of the energy. And then we need to focus on the heating equipment. Whatever the equipment we are using, try to improve the efficiency. We are looking at 20% of saving potential. And then at the last, we only have about 20% of the energy left. So then probably we can get rid of the coal or raw biomass by using this kind of cleaner biomass, like a biomass pellets. So this is the idea. Of course, this is only one solution, possible solution. Could be many other solutions available. To do that, we need to really change the traditional way of cooking and heating. And so basically, traditionally, people use this kind of stove and fuel and to do the cooking and heating. So we want to change it to this kind of heating and cooking behavior, and to use instead of using the raw biomass, try to use the biomass pellets, which is processed biomass, which can burn in a much higher efficiency and low emission. And the same thing for the heating situation. Instead of using coal, which generate a lot of pollutants, and we try to use this kind of pellets. However, to make this really work, there are a lot of issues that need to be considered. Technical issues, economic issues, and also I would like to mention that we also need to consider the users' preference and acceptance. If you provide them something and you think it's going to work, however, when you deliver it to their home and they don't like it, then eventually they are going to throw it away, even though it's a free gift to them. They don't take it. So basically, we are doing something which try to consider their own behavior. So what are their own behavior? They try to use their existing cooking facilities, the most they want. For example, the cooking pot. And so what we did was we tried to keep the same cooking pot, and then just replace the insert a kind of so-called cooking burner and put it inside of their existing cavity, and then try to see if this is going to work or not. So based on our very preliminary test, it seems like farmers like this idea. And so we are doing different stages, so from technology development to the laboratory emission test, and then test it in our rural energy lab with a unique facility. We can mimic the household situation and try to find potential problems. And then we can do the pilot test to deliver it in several households, and then if it works, then we can do a larger scale implementation. So this is a procedure, and we are at this stage right now, and hopefully, if this works, then we hopefully can be another solution to solve the problem. So now I'd like to switch to this part of the problem. In the urban area, the people are exposed to very different kind of pollutants other than the outdoor air pollution. And so there has been a lot of evidence showing that in the urban residential homes, the volatile organic compounds or formaldehyde, they exceed the standard quite a lot. And so based on these many tests, more than 1,000 households tests, so very large percentage have shown the problem. And also based on the chemical measurements, we found that quite some percentage also exceed the guideline value in China. So, so the dilemma is, we know that a lot of materials, they have the standards and they met the standards. Doesn't mean they can ensure good indoor air quality. And secondly, we also know that less VOC content in the material doesn't mean it's less harmful. So that's another problem. And also we found sometimes people use air cleaner. However, we know that sometimes they are not cleaning air, but rather they are polluting the air due to the byproducts or ozone generation. And also we found that some standards or regulations are really contradictory to each other. And also we have found too many green products in the market. However, there are no scientific proof. So these are the real problems. And so what we found was there are lots of a long list. You can come up with a long list of needs, research needs. So I think the first thing, certainly, we need to work on fundamentals, on the material science, and physical-chemical processes, and trying to understand the situation better. So that's certainly important. However, the second one, I think, is also a very important issue, to try to monitor the air pollutants in a more cost-effective and more efficient way. So I use this as an example. Right now, most of the monitoring are based on the laboratory test. So the professional testing company or service company, they come to the home, and then they take the air samples and bring them to the lab, and then they give you a number. That's only one number, and they charge you a lot of money. So it's a very expensive way, and it doesn't really, it's not very convenient way. So if there is a better way, more economical, and then that may be much, much helpful. And certainly, I think there is a need for design tools and also standard test procedures, databases, and new air cleaning technologies. You can come up with a long list. And I know our chair is reminding me, so I will just quickly finish my. So I think the first thing I would like to really mention is that there is cost-effective air pollution monitoring system available. So it can do the online air monitoring, air quality monitoring, and then send the data to a central station, and then you can have a continuous monitoring of the situation. And also there has been mobile measurement units or smart air monitors available which can measure these kind of pollutants in a very cost-effective way. However, you need to calibrate them, otherwise the accuracy may not be satisfactory. And also another work that we have been working on is trying to develop a so-called pre-assessment tool to try to solve the problem before you implement them. For example, if you want to do the interior construction, then you can have a lot of choices of the materials, and then you can do a simulation, and then find that, you can predict what's going to happen. If you find that this is not going to work well, then you revise your design, and then try to prevent the problem from happening in the first place. So that could be another possibility to solve the problem. And of course, this procedure needs a lot of effort. In particular, we need to do a lot of tests on the emission sources to get a database. That's a lot of work. So as long as we come up with that, then the simulation needs to be validated, and then this could be used as a good design tool to prevent the problem from happening. So that's a very brief presentation. Thank you.
Thank you very much, Professor Xudong Yang. And let's welcome Sophia Qiu Yang from Harvard School of Public Health.
And this is a link.